Good morning. Thank you for joining me. This will be the first in our four-part series, webinar series on the Belimo energy valve. Today we'll make an introduction to the Belimo energy valve as a product and give you a little overview as to how it can help solve your low delta T problem. So when we're talking about delta T, we're really talking about delta T at the coil. And so what we're referring to is the difference between the supply water temperature which enters the coil and the return water temperature that leaves the coil. And when it's low, it means that I have not exchanged a whole lot of BTUs into this space, or more accurately, haven't transferred enough heat into that water. Low coil delta T means that I have inefficient heat transfer. It means I sent very cold water to my coil, and it's still pretty cold when it heads back to my chiller plant. This is typically caused by increased GPMs. So I'm flowing more water to my coil, but due to my low delta T, I'm not generating an increase in the total number of BTUs produced, and therefore I cannot offset any additional load in that space. So I'm pumping more water, and I'm not creating any more BTUs. When I pump more water, obviously I have to use more pump horsepower to pump that water, and I'm reducing my overall plant efficiency. Let's take a look at a coil curve and talk about how we can get into trouble here. This is a typical coil characteristic. You can see at low flows, the curve is a little bit steeper than it is as flows get higher. What I mean by that is at the low end of my coil flows, a relatively small increase in flow generates a much higher increase in BTU. As I get up into higher and higher flow ranges, this heat exchange becomes less and less efficient. Here near the top of the curve, we can see that it takes a substantially higher increase in GPM to get a relatively modest increase in the number of BTUH. This curve is governed by the following formula. Power output equals 500 times the GPM times the delta T. So you can see that the load into this space is dependent on both flow and delta T. Let's take a look at a single point here on my curve. This is in about the 270,000 BTUH range. And notice the point cloud surrounding this line at this point has a certain thickness, and that I could create this same amount of load with a fairly large range of GPMs. So if we can take the formula at the bottom and say that my load is fixed, it's fixed at 270,000 BTUH, but I can do it at a variance of flows, well that means that I would also have to vary inversely my delta T. So let's add delta T to this graph. And you can see here that as I put more flow into the water for the same load, that I will see a reduction in the delta T value. So if my load is fixed, flow and delta T become inversely proportional. So at a fixed load, less water means higher delta T. This curve has been truncated at a point where it is no longer efficient to pump additional water. However, if we continue pumping water, this is what happens. My coil curve is now completely flattened out, and I'm no longer producing BTUs. The only thing that happens if I increase flow now is that I reduce my overall delta T. This curve has a certain degree of thickness to it, but imagine how many different flow rates we could create the same load if we had a curve that looked something like this. Well, let's go ahead and talk about the Belimo energy valve. The Belimo energy valve can do several things. It measures energy, it controls power, and it manages delta T. The Belimo energy valve is a pressure-independent valve with a fully integrated BTU meter. It has several benefits. We can simplify the total control strategy. You can deliver the exact amount of GPMs required at the coil, or the exact amount of BTUH required in the space. Save energy. If we can use less water to satisfy the same load, obviously we can save energy. And we can also track equipment performance. The Belimo energy valve has a fully integrated onboard BTU meter and a full BACnet communication module. That means that measurement and verification can come directly from your control valve. Let's take a look at what goes into this product. Let's start from simplest and move to the more complex. Up front we have a standard control valve. This is a typical characterized ball valve up front. Sitting on top of that is an actuator. This is probably the most technologically advanced actuator ever produced, but at the end of the day, you give it a 0 to 10 volt signal and it rotates 90 degrees, so it's an actuator. Sitting on the back side is what gives it all its smarts. Here we have an embedded flow meter right into the valve. And then we've also added a couple of temperature sensors. This one here is integrated into the valve housing, while the other one gets plugged in on the opposite side of the coil. Now we're measuring flow and delta T, and by the formula we used earlier, we can calculate BTUH. In order to get all this information we're collecting out, we have also integrated BACnet into this product. So if we're measuring flow and we're measuring delta T, it allows us to do a handful of things. First and foremost, we can measure, observe, record, and trend performance data. The Belimo Energy Valve is recording data constantly. It has the capability to store over a year's worth of data locally on the actuator. It also allows you to push your data out through BACnet, and it even has an onboard web server if you want to log in and take a look at what's going on in real time. If we're measuring flow and delta T, we can also control directly to GPM or to BTU. We're measuring both GPM and BTU, and therefore we could correlate our control signal to control either one of these two items. And thirdly, by measuring flow and delta T, we can limit waste by managing the delta T. The Belimo Energy Valve allows you to set a delta T set point. The set point is really more of a threshold, and it will not allow the performance of the coil to stay below the threshold that we have set. This forces less water into your coil and creates a more efficient heat transfer process, and that means less GPM to create the same load. Let's explore in a little bit more detail the benefits of using the Belimo Energy Valve. Saving energy. High delta T means more efficient heat transfer. Well, that's what we just talked about. If I can drive my set points further back on this curve, as you see here, well, then I'm using less water to satisfy the same load. Simplifying control. I can deliver the exact flow to the coil using the flow control module. What this does is it measures the flow through the water, and it'll open or close the control valve to hit the set point that is sent by the controller. Well, this is very similar to the way that a pressure-independent VAV box works, only this is done with water. You still send it a 0 to 10 volt signal or a 0 to 100% control signal, and it interprets that value as a specific GPM. Then it measures the GPM it's currently flowing and adjusts itself to the value that you're requesting. A similar process can be done by adjusting the BTUH setting. This means that instead of modulating directly to the GPM requirement, it will modulate to 0 to 100% of the load requirement in the space. Let's talk about a clear benefit of controlling directly to BTUH. Well, by producing the exact amount of BTUH that is required in the space, you get the same amount of heat transfer regardless of system fluctuations. That means you're no longer dependent on disruptions due to supply water temperature, supply air temperature, or other factors within your system. The valve can compensate for all of these changes. This frees up the automation system to only respond to actual changes of load in the space. This valve is pressure and temperature independent. In addition, we're going to track system performance. The more you know about your system, the more efficient you can operate it under its current conditions. That's the whole concept behind continuous commissioning. The integrated BTU meter gives us obviously instant feedback, but it also gives us trending and long-term data so that we can make smarter decisions about maintenance, control strategy, and other types of things that we would want to have for a more efficient building. So to recap, we talked about a handful of things. With the energy valve, we're going to simplify our control. We have the potential for saving energy, and we can also track system performance for ongoing commissioning or just straightforward measurement and verification processes. Let's take a look at one little set of data here before we close out. This is specifically about energy savings and the idea of using delta T management. What we're looking at here is some data that was retrieved from a large technical company's facility that's located in North Carolina. They installed an energy valve on several air handlers. This is data from just one of them. This energy valve was installed on an air handler and then operated in 3 different modes over 3 separate time periods. During the first time period, it was operated in position control mode. Position control mode most closely correlates to a standard control valve. That means that the control signal sent to the valve dictates how open or closed the valve orifice is. This is a pressure-dependent function and will have a lot of variation of actual flow. What you're looking at on the graph is tons of cooling across the bottom and measured delta T across the y-axis. So you could see here that in position control that there was a fairly large load range, but we also saw a wide variance in delta T performance, anywhere from maybe 4 or 5 degrees Fahrenheit to as high as 7 to 7.5 degrees Fahrenheit. On the same valve in the same air handler in the subsequent period, the valve was switched from position control to flow control. Flow control is most accurately correlated to a pressure-independent valve. This means that the control signal is controlling not how open or closed the valve is, but the number of GPMs that's going through the valve. In flow control, you can see that we satisfied a similar load range. Again, remember this was a different time period, so we'll have some different environmental conditions, but more or less the same type of loads, and we were doing it closer to 9 to 10 degrees F of delta T. So that would mean that we're using less water to create similar or same types of loads. And then the third subsequent period of time, they left flow control operating and added delta T management. So now they were able to set a delta T threshold, force the valve to operate at higher delta T ranges. And you can see here we're still offsetting the same types of load, same load range, and now the delta T's are closer in that 14-15 degree range. To magnify the impact here, let's take a look at a single load point. We'll take a look at that 60 tons. So for 60 tons, position control was operating at about a 6 degree F delta T to satisfy a 60 ton load, and that took 240 gallons a minute. So that's what it would take at a 6 degree delta T to achieve 60 tons is 240 gallons a minute. If we take a look at flow control, the same 240 tons at a 10 degree delta T, or roughly thereabouts, requires only 144 gallons a minute. So we reduced the flow by almost 100 gallons a minute to create or to satisfy the same 60 ton load. Then we engaged delta T manager for that third period of time. Again, it's the same air handler in the same building, third period of time with the same energy valve, and they engaged delta T manager. Now we're getting delta T's in the 15 degree F range, and so to offset a 60 ton load there, now we're only requiring 96 gallons a minute. So between position control and delta T management, we're able to reduce the flow rate to about 40% of its original value. So we're under 100 gallons a minute, we're still offsetting a 60 ton load, and we're using significantly less water to do it. So this is a fairly impressive result and certainly has an enormous impact on the energy consumption at this facility, both in pumping power and general plant efficiency. Well, thank you for joining me today on our introduction to the Belimo Energy Valve. To learn more about Belimo Energy Valve, go to www.energyvalve.com or reach out to your local Belimo representative or distributor. If you'd like to join us for future webinars, we'd love to have you. Upcoming, we have on April 24th, Understanding Coil Efficiency and Managing Delta T. That'll be a much deeper dive into Delta T management and how that works. In late May, we're going to take a look at advanced control strategies, how flow control and power control can benefit you. And on June 26th, we're going to talk about how the communication modules work, including BACnet, WebView, and a few other tools that we have in place. So thanks again for joining me. If you have questions specific to this webinar, go ahead and forward them to our marketing department at marketing@us.belimo.com, and one of us will get back to you shortly with an answer to your inquiry. Thanks again for joining us, and have a good day, and hope to see you at our next webinar.